All right, take it away, Rick Thoman.
Okay, thank you very much for that very kind introduction, Gay. And so as Gay mentioned, kind of have a potpourri for you this evening. So since the last time that you had me on Straight Science, which was right around Halloween, we'll take a look at what's happened basically since then across Western Alaska and Bering Strait region. Take a look at the outlook for the upcoming summer, and then a couple of special features tonight. As was in the news, NOAA just last week released the once a decade new climate normals. So we'll take a look at, see how that's changed for Nome, and then finish up with a lot of consternation and gnashing of teeth about the loss of some basic climate data with the Weather Service pulling out of Western Alaska. And there's, at least for one thing, there's something that, that folks can do that might be really valuable in getting that snow information at low cost. And I hope that we'll get some takers on that. So that's what I have coming up for you here tonight. So taking a look, since November 1st, here's daily temperatures, departures from normal for Untitled on top and Nome on the bottom. And unlike some of these graphics that I've shown in previous Straight Sciences, not completely dominated by above normal days, more days above normal than not at both Untitled and Nome over the last 6 months, but not dramatically so. Now, having said that, of course, as you may recall, generally warmer than normal, not monolithically, but warmer than normal early part of winter, and then in late January, turning colder and more colder than normal weather than not, but again, not monolithic, into April before the pattern changed. So nice to see some blue on these daily temperature plots here. So if we look at temperatures, and here we're going to do temperatures relative to the 1961 to 2000 period, so 60 years, and this is where the November to January temperatures ranked. Anything that's in a warm color here, which is most of this graphic, fell into the significantly above normal category. For most, but not all of the Seward Peninsula, as well as St. Lawrence Island and the Bering Strait, this November through January fell into the top 10 warmest. Since 1961, so in the last 60 years. The kind of the eastern Norton Sound, the eastern Seward Peninsula area, southern Norton Sound coast generally fell into just the significantly above normal category for that 60 years. But interesting kind of spatial distribution here. And you can see that that was the case across effectively all of mainland Alaska there. So that's the first half of the cold season. Different picture when we go to February, March, April, same scheme, 60 years. We're looking at this winter relative to that 1961 to 2010 period. The white area, white space there, is where that 3-month period, the average temperature fell into the middle, so the near normal category. Notice below normal extending into, significantly below normal, extending into eastern Norton Sound and the eastern and central Seward Peninsula, but not as far west as Nome or through the Bering Strait and St. Lawrence Island. Now, notice to the south of Western Alaska, Southwest Alaska, down towards the Pribilofs and the Aleutians, it was an extremely warm late winter season here, with St. Paul had amongst, I think both, let me think, March and April fell into the top 5 or 6 warmest in the last century, not just the last 60 years. And that's been accompanied by very warm sea surface temperatures And that could be an issue for Western Alaska as we go into the warm season here. So I did want to, so we were just looking at kind of how this past cold season stacked up against the previous 60 years. Now here's a graphic from my favorite climate analysis model that we have fairly newly available. And so here we have a plot of temperature departures from the normal for the midwinter period. So kind of the classic December, January, February. And quite interesting here, you can see that most of the Seward Peninsula was a little bit below normal for the 3 months, but not the case along the coast from about Safety on west, and significantly above normal there through the Bering Strait and for St. Lawrence Island. Of course, one of the things I love about this is we get that kind of regional detail or sub-regional detail that we really can't get out of the very few even temperature observations, which we have comparatively a lot of as compared to precipitation. So I wanted to put this in context. I showed this graphic in October. We had a La Nina this past winter. So that's La Nina, El Nino, probably the best known of the kind of the seasonal to annual scale, global scale climate forcing mechanism, and it just refers to how temperatures are varying along the equatorial Pacific, so 1,500 miles south and southeast of Hawaii. How could that possibly affect Western Alaska winter weather? Well, it's because those equatorial sea surface temperatures in turn affect where those giant tropical thunderstorms form, which in turn influence the jet stream across the higher latitudes. And so that's how temperatures a degree or more above or below normal along the equator can affect our seasonal weather. In past years, when we've had La Ninas, most of the winters, the midwinters here we're looking at, December, January, February, wound up at least somewhat colder than normal, but with some big swings. So for instance, 1989, 88, 89 is in there. Stormy December, then the super cold January, followed by the super warm February. Similar flip-flop in 2007-8. This year, not so much. Came out for Nome, averaged a little bit above average, not dramatically, but no real big flip-flops in the midwinter time period. And it's a nice illustration of a couple of things. One, there's no one cause. The El Nino, La Nina signal that's just one piece of the puzzle. And the other thing that this is, I think, a nice illustration of is that the conditions going into midwinter, particularly the ocean and the ice conditions, are now very different than they were, of course, prior to the 1990s. And so it's not surprising that we see different outcomes when we're just looking at what's going on in the equatorial Pacific. The conditions closer to home going into midwinter are nothing like they used to be. So it's not surprising that we see this relationship not holding up as well. All right, precipitation. Again, so from the climate analysis computer model for November through January, again, we're looking at comparing the precipitation in this past November through January to the previous 60 years. And you can see all of Western Alaska falls into the significantly more precipitation than average. And interestingly there, western part of St. Lawrence Island and through the Bering Strait, Diomede fall into the top 10 in the last 60 years, wettest November through January. Now, of course, for most of Western Alaska, not all of that precipitation fell as snow. Significant rain in many areas in early November. So this is rain plus the melted liquid equivalent of the snow. Now, when we jump to February to April, very interesting pattern. Notice St. Lawrence Island, wetter in this past February through April in this analysis than any 1961 to 20 winter. And again, all of Western Alaska winding up in the significantly above normal category. Now, we of course have issues with precipitation in Nome with nothing but the automated observation at the airport. But I thought I'd take a look at what I could pull out of this. I've got a little bit more detailed analysis of this that's in the nugget this week, but I thought this was pretty nifty graphic here. What I did, I started this. This shows the total accumulated precipitation starting November 15th. So this is about at the start of the snow that came and stayed season. There was snow in late October, but if you recall, the storms in early November produced significant erosion and were mostly rain. And so we wound up going into the second week in November with no significant snow on the ground in Nome on the coast. And what's interesting here to me is, okay, you can see there's several nice step ups here. I don't know if you can see my cursor there. So these indicate significant precipitation as recorded by the automated observation at the airport. And most of these had a significant wind too. But overall, the total precipitation was pretty close to normal. The way I've highlighted this, the blue indicates that what fell was above normal, and the orange here, the total since November 15th was below normal. So we were mostly running above to near normal. And then, of course, March came, and 6 big storms between March 6th and April 19th. And you can see the total precipitation really went through the roof here. Now, I did have to estimate the big storm, March 6th to 8th. The automated observation at the airport was not functional from the 5th to the 9th. Or thereabouts. Didn't go down because of the storm went out before that. So we lost that information. And by this point, the rain gauge at KNOM was getting buried just from the drifting. And so I think, though, this is a pretty good estimate of what happened. And it really illustrates, once again, how dramatically late season loaded the precipitation was for Nome this past cold season. So one of the things that we can get out of our climate analysis model is an estimate of snowfall. So again, at the local scale, this is probably not, you wouldn't want to use this to get a guess of how much snow fell in any one place, but regionally, I think it's pretty good. And you can see that most Nome, all the Bering Strait, St. Lawrence Island, very high snow relative to our 60-year reference period here. That area of not quite as much snow to the west of Nome, Teller, Brevig area, that is kind of interesting. Obviously, we don't have any data to thumbs up or thumbs down that, but it's interesting to see that. Show up. Notice Eastern Norton Sound and the eastern southern Seward Peninsula fell in the significantly above normal snowfall category, but not as high as Nome, and definitely not as high as St. Lawrence Island, where easily in the top 10, and at least according to the model here, Gamble second most snow in compared to our 60-year reference period. So only 1 year, 1961 to 2020, would have had more snow in this model analysis. So really, and I think everybody is well aware of that. Folks on St. Lawrence Island, of course, have been talking a lot about how much snow there was this winter. So we kind of get that anecdotal verification. All right, sea ice, quite a bit of different story this year than we saw last year. On the right-hand side is the maximum sea ice extent from 2020. On the left-hand side is the maximum ice extent from this year. And you can see on the left-hand side, the ice did not ever get very far south of St. Matthew Island, never came close to the Pribilofs, never got very far down Bristol Bay. That's quite different than last year when the ice did get to St. Paul for just a couple of days, but it did get to St. Paul, and ice at its maximum did extend farther down Bristol Bay than it did last year. So not at the calamity of 2018, but certainly less than last year, at least in the seasonal maximum level. And this slide, this is my this is just a plot of the daily sea ice extent for the Bering Sea from the National Snow and Ice Data Center. Daily satellite estimate. The blue line is this year, and you can see that from February through late March, that the sea ice this year ran lower than last year, and every day this season, sea ice has been below the 1981 to 2010 median extent. So again, not as bad bad in the sense of extremely low ice extent as 2017, 18, and 18, 19, but not up to historical snuff. All right, so that's where we've been. Quick look here at our outlooks for the coming summer, and we'll start off with melt out of sea ice and then temperature and precipitation outlooks. So this is from the outlook made in late April from the Climate Prediction Center's experimental sea ice outlook. And this is outlook. This is the average of 20 different computer model simulations. And what is plotted here, this is the first date that the sea ice concentration gets down to less than 15%. So we have open water. And this is pretty messy, if the raw data, so I just binned the data here into half-month intervals, so early and late the months. Now, this does show significant changes from the forecast that was made in late March, which had a much later melt out of ice. In fact, didn't have ice melting out in much of Norton Sound until early June. Okay, that's not going to work out. So this overall looks pretty reasonable. Notice that ice, we don't get any, the first date of open water in the Gulf of Anadyr, especially towards the coast, is in early June. That's pretty typical. We already, of course, have open water first half of May over now, a large portion of eastern Norton Sound, as well as near the southern Seward Peninsula coast and up into to north at Diomede now. On the other hand, there's really no sign yet of any kind of breakup going on yet in Kotzebue Sound. So all in all, this outlook from the Climate Prediction Center looking pretty reasonable, and certainly more reasonable than what we saw from last month, but that's probably good in the sense that it's made 1 month later and so closer to things happening. So we're going to look at the monthly outlooks here, and this is from our colleagues at the World Climate Service. And so this is for June. Temperatures are on the left, precipitation is on the right. Now this is using two different climate model systems, the main US climate model system as well as the main European system. Now what this product does, and it's different than some other products, is this takes into account how good the models are and their systematic errors, and corrects for both of those. So the outlook for June temperatures, you can see almost everywhere favors significantly above normal temperatures. That's the warm color. That little blue ball there in the Gulf of Anadyr looks suspiciously like a sea ice induced feature. Last month, this particular product had the same feature, but it was farther to the east and a little bigger. So whether that's real or not, hard to say, but I'm fairly sure that is sea ice induced. The models think that sea ice through into June or through most of June would be unusual there and cooling. Now, this is still using the old climatology, the 81 to 2010. So I'm somewhat suspect of this. The main thing I get out of this is there's a warm tilt for June over most of, well, effectively all of Alaska, really, including the Western Alaska. Precipitation, on the other hand, shows a whole lot of nothing. And that is not surprising because this model, this product here, takes into account how good these climate outlooks are. And frankly, summer precipitation climate models do not do well in our part of the world, as in Alaska, high latitudes. They just don't do well with early summer precipitation. And so it's not surprising to see all white space here. The models simply aren't good enough to give us any kind of hint in above, near, or below normal precipitation for June. Pretty much the same story in July. You'll notice that cold ball there in the Gulf of Anadyr has gone away. Generally a warm tilt across most of Alaska and Western Alaska, but not so much in St. Lawrence Island and the Seward Peninsula from about Nome west. Again, I think that's probably sea surface temperature related. So my confidence of that is not high, but certainly on the larger scale, the Bering Sea, North Pacific, Alaska, Eastern Asia scale, generally a warm tilt for July. Precipitation, nothing comes out of the models of any skillful nature. And the same for August, really same story. So pretty consistent temperature outlook for all 3 summer months. And in this product, really there's nothing to tilt the odds in any direction for the precipitation. Now we can look at the Climate Prediction Center, so NOAA's Climate Prediction Center, and these are the outlooks that were made the middle of April. And so the May to July, so we're just 2 weeks into May, so most of this is still to come. And the information that the forecasters had available led them to this forecast, which is a warm tilt for the 3 months as a whole, all across Western Alaska, with slightly lower chances, say, southern Norton Sound coast, but generally a warm tilt. And now, interestingly here, we see a wet tilt on the right-hand side. That's the precipitation probabilities. And this, this might be okay, given what we've had so far in 2021. It's been fairly wet, at least for the southern Seward Peninsula. That hasn't worked out north of Kotzebue everywhere, but this is in some, I think this is mostly tied to the idea that ice is going to break up fairly early, and so we'll have more exposed water. And this is for a 3-month season, and we're just getting into the start of the rainy season in Western Alaska in July. So the probabilities are not high here. Kind of my little scale here. So this darker green area, just picking the middle values, 45% chance for significantly above normal precipitation, but that also means then that there's a 55% chance for near to significantly below normal precipitation if this is an unbiased forecast. So it does, for this 3 categories, significantly above normal is the most likely, but one of the other 2 is more likely than this. So that's a pretty weak tilt. When we get, like we have with temperatures in northern Alaska, up above 50%, that becomes much more significant. That's pretty rare with precipitation. Just so hard to do precipitation forecasts, especially in the warm season. And for June through August, not much change everywhere in Alaska. Tilt's warm. Now we see that this significant 50% chance for significantly above normal does extend across the northern 2/3 of the Seward Peninsula, Bering Strait, south of there, in that little bit lower category. And they never color St. Lawrence Island, but St. Lawrence Island should be in this 40 to 50% chance for significantly above normal here. No surprise there, given the model guidance. Precipitation, CPC stuck with their guns here and keeping a slight wet tilt in the odds for rainfall for the summer across Western Alaska. All right, so that's where we've been and what the outlooks indicate, such as they are. So now we're on to the new climate normals portion of the program. So won't have to listen to this part again for another decade. So what's happened? So by international convention, climate normals are updated once a decade on the the whole decade. So 2020 is the end. So the new climate normals are for the 30-year period. Again, that's by international convention for 1991 to 2020. Now, I do want to stress here that what's happened here, we've updated from 1981 to 2010 to 1991 to 2020. So 20 of the 30 years are exactly the same. So when we look at changes in the normals, all we're really seeing is the difference between the 1980s and the 2010s. And there's only 10 years in there. So what that means is that one or two unusual months, say in the 1980s, can show up as a big change in the current normals, not because necessarily the long-term climate has changed that much, but rather we've dropped out some extremely warm, extremely cold month, extremely wet, extremely dry month. So that's important to keep in mind. I'm afraid to say that since the climate normals have been released here last week, there's been a lot of comparing normals and, oh, look how the climate has changed, without taking this important factor into consideration. And we see that very clearly here in Nome. What's the biggest change that you see between the new normals and the old normals? And it's April. The new normals, 2.1 degrees warmer in the new normals than in 1981 to 2010. Why is that? Well, it turns out, for those of you that have been around for a while, you might remember 1985 was an extremely cold April. In fact, it's 10 degrees colder than any other April in the last 40 years. And so just by dropping out that one April out, that accounts for about more than a third of that increase in the April temperature there. It's a good example of how one outlier can really influence this. We'll see the same thing in 10 years when September 1992 drops out of the normals, because that was such an extremely cold September, nothing like it. But overall, here's the changes that we see in between the new normals, 1991 to 2010, and the old normals, 1981 to 2010, 1991 to 2020. So you can see 9 of the 12 months are warmer. Some of the changes are really tiny. Really, it's only March is the month that shows the most cooling. December shows about a ½ degree cooling. That again, that's in part due to there were several very warm Decembers in the 80s that have dropped out. So not quite as dramatic as in April, but that's what we have. The overall average temperature for Nome increases by 0.6 degrees up to 28 degrees now. Now here's the changes in precipitation, 1991 to 2020 compared to 81 to 2010. March, you can see, has a significant increase there, 14% of the normal. Same increase in October, the biggest drying in September. Again, we had a really wet September drop out from the 80s. Overall, though, a little bit of increase, about 0.4 of an inch, but as a percentage, that's pretty small. So a little bit wetter, but nothing really to write home about. Now, we still got we got enough data to look at changes in snow, and this is kind of interesting. And I think this will comport with people's experience. Basically, early in the winter, not very much change in the normals, but it's February and March where the normals really bang up. 20% more snow in the new normals in both February and March, but then a decrease later in the spring. And some of that, of course, is not necessarily due to less precipitation. Some of it, for instance, as we had in April of 2020, lots of precipitation, but most of it came as rain. So some interesting seasonal changes here in snow, and Nome is not unique in that regard. We see those kind of interesting seasonal changes elsewhere in Alaska too. All right, so last portion of the program. Okay, so since the fall of 2019, Weather Service isn't measuring snow anymore. KNOM is trying their darndest to be a cooperative observer and measure precipitation and snow, but first of all, it's an extremely difficult job for anyone, and they weren't really set up to do it right, especially in high snow years. Being in town, drifting around the buildings makes it very difficult, and having a snow gauge or precip gauge that sits on top of the snow is just not a useful thing in Western Alaska, especially by the time you get to the late winter time. And several of the storms in March and April, the precipitation just got buried in the drifts. So probably nothing we can do about that. Hopefully the Weather Service can do something to help KNOM get more reliable data by elevating that rain gauge. But for snow, we might have a partial solution. The Natural Resources Conservation Service which is part of actually the Department of Agriculture, I believe. They do lots and lots of snow measurements around the country, but especially in the Western Lower 48 and in Alaska. One of the traditional tools that they have are what they call these snow course observations. And so this is just a predetermined transect where a few times a winter, people go out and you measure snow depth and you measure how much water's in that snow, so to get an idea of the snow water equivalent. NRCS has lots of these snow courses in the Western Lower 48 and in Alaska, where the people doing the observing are not Natural Resources Conservation Service personnel, but rather what they call cooperators. So people that go out and volunteer their time to do this, write down the information and report it back. And I think that this is a potential solution, partial solution, for the loss of snow information in Western Alaska. Typically, these observations are made just 2 to 4 times a year. February to March is ideal. It's typically done around the 1st of the month. NRCS, I've talked to them about this. They are willing to provide the equipment necessary. Once you get your snow course determined, when you go out to make a measurement, it takes 2 people. You can do it in a couple of hours. To initially set up the snow course, might be half a day. For Western Alaska, it's going to be really important that local knowledge get used in this if we want to do this, because what the instructions say is find a place that doesn't have drifting snow. Okay, there is no such place in Nome, right? But there are places where the drifting tends to be more uniform. If we can find a place that there's land access, that has relatively uniform drifting most of the time, and importantly, that doesn't get much or any snow machine traffic, that would be a place to set this up. If we can find an organization, and NRCS is clear on this, they don't want individuals volunteering because they don't tend to last very long. They want organizations that are willing to commit to 2 to 4 times a winter around the first of the month, February, March, April, May, go out and measure this, typically 5 observations along your preset transect, write that down, send it into NRCS. I think this could be a really good source for getting an idea of how much snow and snowpack, how much water we have. There is history for this on the Seward Peninsula. Back in the 1980s, I believe the DOT was doing this out the Cougar Rock Road. It was a site called Cottonwood. I don't think it was done more than a few years, but it really provided some really interesting data. And I think that now that Weather Service is not doing this anywhere, doing snow anywhere in Western Alaska, that this is potential for folks in the region to step up and help get this information that is going to become really important. Now, as I said, we can get this seasonal scale snow depth, snowpack information out of this. It's not going to help with, how much snow did we get in the storm over the weekend, right? Snowfall is completely different. That really can only be done daily, and we're not getting that unless Weather Service can get KNOM set up better. It doesn't help with snow on/off dates, but it would get us some seasonal snowfall, seasonal snow depth, and snowpack information. If you work for or know folks in an organization in Nome, in any community in Western Alaska that you think you might be willing to do this, and again, it's a very low time commitment, and NRCS is willing to provide all the equipment that you need. So once the site's set up, which probably would take an afternoon, it's a couple hours for a couple people 4 times a year, 1 day a month from February through May. It's really pretty easy, and I think it would provide really important information, not just for climate scientists, not just for the River Forecast Center, but for the region. As we can build up this information, then we'll have a sense of how, a quantitative sense of how is this winter, the snowfall this past winter compared to previous years. On this slide, I do have contact information. You can, of course, get a hold of me and Daniel Fisher, who is the NRCS data collection officer. He's in Palmer. He knows I'm giving this information out in this presentation, and he's very happy to field questions from folks if you want to work with him directly. But I think this is a really, really good opportunity for folks in Western Alaska. We can help ourselves in this. Automated weather stations are incredibly expensive and costly to maintain. This is a very low cost way to get some very important information for the region. With sea ice decreasing in the region, at least in the short term, snowfall is going to likely go up. I think this could be really valuable. So I'll get off my soapbox there and say koyanak. And I think most of the folks on here already know about it, but if you don't, we do have our Seward Peninsula Bering Strait Facebook group. Please join. And if you're on Twitter, I post a lot of Alaska climate stuff. I'm Alaska Weather. So that's the entirety of what I know.
I doubt that, but thank you, Rick. And before we get into questions, and I know I've got questions, I hope everyone has questions for Rick. We do have a caller. So it is difficult to be a caller on a Zoom call. So I'm going to ask the caller, do you have any question? You get priority, caller, if you have a question. And I might have muted you. So you may be muted. And you shouldn't be muted now.
No, I'm good. I don't have any questions. This is Mike Weber.
Hi, Mike Weber. Where are you calling from?
My house.
Okay. You're in Nome?
I am, yes.
All right, rock on. Thanks. And thanks for sticking with us. That's great, calling in. All right, so we'll open it up to anybody else who has questions. You can either type in on the chat, which looks like a little cartoon bubble on the bottom of your Zoom bar, or feel free to unmute and ask, or some people are fancy enough to know how to raise their hand. Well, I'll start off. And you had a slide, Rick, that was one of the midwinter slides, and it had, you had the really strong band, I think it was of the orange in the water down below. It was one of the first ones. There, one more down. Yes. So what I noticed was you have a lot of heat in the northwestern Chukchi Sea, over there on the top of Chukotka. Is that what? Any ideas? We know that they had warm weather last year. Is this something, you know, we can't see beyond that, but is this looking like they are having? Is that related to like their ice, or is that residual to what they experienced this past year?
Yeah, so I think it's this area here that you're referring to.
Yeah,
so I think
incredible.
I think this is in part reflecting the very late freeze up in December. So I think this is reflecting mostly that very warm start to winter. If we look, if we go to this one here, the February through April, pretty close to normal in that part, at least in the normal category. So I think this is reflecting the late freeze up. And then of course, even into January, when we had the liquid natural gas tankers, icebreaker assisted, but still the ice was thin enough to go up this way. There was still heat coming off of the water underneath that thin ice. So I think that's a reflection. That's what this is showing here. Right. And certainly over here in the Gulf of Anadyr, this is definitely reflecting the late freeze up that happened in this area.
Well, thanks. And for those tankers that we saw in January, those were unassisted in January. They were cruising at 9.5 knots. The one in February that was escorted north from Big Diomede back to the Yamal Peninsula, even in that area, that red area where the ice was weaker, I know this is temperature, but the ice was weaker between Wrangel Island and the coast. They didn't choose. They went straight up. Those tankers didn't choose to go in the easy ice. They didn't have to. But thanks. Yeah, that got my eye. Anyone else with questions? I don't see anything in the chat. Another question. If in Nome, this situation with the weather service and the automated weather, you call it the ASOS, the automated weather machine at the airport goes down, and then we don't have anyone to fix it, and then we have to wait till the storm's over so they can send somebody out to fix it so we can get data, but the storm's over by then. Who would be the most appropriate person if someone from the Bering Strait region or Nome wanted to maybe let the weather service know that it's something that we would really like to see if people wanted to do that? Is that Fairbanks or Anchorage?
Yeah, call Fairbanks Forecast Office.
Fairbanks Forecast Office. All right.
If you call Anchorage, they'll say, "Oh, well, that's in Fairbanks's area." Even though, because of the Alaska Airlines flight schedule, the electronics techs are coming out of Anchorage, it's still Fairbanks's responsibility. So, yeah, call them.
So the Fairbanks Forecast Office. All right.
Hey, Gay, I have a question there for Rick.
Go ahead.
Yes, Rick. So it looked like you showed summer temperatures overall warmer than normal for most of Alaska. And I'm wondering, looking, you know, considering ocean temperatures there, are you also looking at what, sea surface temperatures, or how do ocean temperatures fit into this picture? I'm just wondering, are we looking at maybe another real warm summer or warm summer ocean temperatures?
Yeah, so that is an excellent question. And I think we can partially get at that here with the monthly products here from the World Climate Service, that don't stop over, you know, they go out over the water. So this is the air temperature, but of course over the ocean, this is effectively reflecting what the ocean temperatures are. And in addition to that little cold ball, which I think is ice related, later in the month or later in the summer, this weakness continues. And I think what's going on is that the water down here, south of the ice edge, so outer Bristol Bay to north of the Pribilofs, really all the way to the Russian coast, that water has been above normal all year since January. And it's been very stable. And it's one of the reasons that the ice was never able to push very far south of St. Matthew. This water is still well above normal, which means, of course, now at this point, it's warming up. This area up in here, I think the models are keeping this cooler because of the presence of ice. I mean, we've still got a fair bit of ice, even though it's getting Swiss cheesy now. The models are keeping the ocean surface temperatures cooler up in, say, here, St. Lawrence Island northward in July. And I think that's due to maybe a more normal timing of melt out of the ice, whereas this water is already above normal. No reason to think that that will change. Now, what of course could throw a big monkey wrench in all this, especially given that we've got this warm relative to normal water down here. If we were to get some weird out of season storm that produced a lot of south wind and accelerated the Alaska current north, we could see things change in a hurry, I think, in the northern Bering Sea, and all of a sudden temperatures, pop up in the ocean relative to normal. Now, will we get the fish killing heat in eastern Norton Sound? That will depend on the weather, because of the shallow water in eastern Norton Sound and the currents. That's very much determined by what the weather does. If we get big, hot, high pressure build, then the water will heat up really quickly in eastern Norton Sound. But out in the more open ocean will in part depend on the timing of ice melt and what kind of push we get from the south.
Okay, thanks. That's really interesting. And at the risk of having Gay mute me for the next question or follow-up question, so we work at the ready.
No, I'm just kidding.
We work with marine mammals, mainly sea lions, throughout from Southeast Alaska all the way up into the Bering Strait. And I'm just, we saw quite an impact, it seems, on adult female survival after, starting around 2016, 2017 in there. And so I see all that red out in the ocean, and I'm just, I know your focus is up in that Bering Strait, northwestern Alaska, but any insights, if I dare ask, on the rest of, say the Gulf of Alaska?
Again, to the extent that these models, the air temperature over the open ocean is going to very closely reflect the sea surface temperatures. This would suggest that above normal sea surface temperatures are more likely than not over the Gulf of Alaska. That's certainly been the trend over the last few years in the Gulf compared to the historic average. I think in the Gulf, 5 of the last 6 years are in the top 10 warmest in the May through October period since 1900 and now this is for the whole Gulf of Alaska, but the trend is certainly for much warmer than it used to be.
Great, thank you so much. Very interesting presentation. Really appreciate it.
Bet.
And that is a good reminder. Thank you, Lori. And that's a good reminder. Be sure if you're a participant, it's really become a thing that the participants, we asked to share some love for Rick Thoman. It's not easy to be presenting after dinner and after a long day. And so it's really nice to show some love there for Rick Thoman reaching out to us here above and beyond duty. So we really appreciate it. The other thing I would add too, when you were talking about the temperatures, Rick, we do have, I think there is someone from the NOAA Race Division in the audience, and we're glad to say that they're coming back to do their fish survey, and we should have some really terrific information on bottom water temperatures and also the results of how the fish numbers are, given that we've had a big switch up here in the last 4 or 5 years or more. And so they will.
So can I add to that?
Yeah, absolutely.
So there is a ship out there now. Is it the Oscar Dyson?
I believe the Oscar Dyson may be out, but it won't be up this far north.
No, no, it's not up that far north. But I did hear, so they're about at St. Matthew Island right now, and I did hear earlier this week. This comes as no surprise, right, given the ice situation. But between St. Matthew and St. Paul, they found no bottom cold water at all. It was completely mixed out right down to the bottom on the continental shelf here. No surprise, there was never any ice there. It was fairly stormy. So be interesting to see what we get with the surveys later this summer all the way up north.
Yeah, so that's a bit of that's very interesting. Thank you for passing that along, Rick. The yes, the NOAA Race Division will be doing their survey of the southern Bering Sea, and then they'll come up and do the northern Bering Sea all the way to Diomede. And Dwayne Stevenson and Lyle Britt are leading those, and they have actually said they would, right after they come back and they'll be writing their report, they will be doing a straight science with them. So that's really exciting, and we look forward to that because that's going to be very telling, especially since we haven't had any kind of peek into the ocean with the COVID pandemic canceling the research last year. All right. So anyone else with a question? I don't see anything in the chat.
Oh, I see a question in the chat there.
You do?
Yeah.
I must have hit it. Go ahead.
So Mary asked, what type of equipment does NOAA use to track this data? Is it the same type as which monitor tsunami and earthquakes? So a lot of what you're seeing here, Mary, is being derived from satellite. There are very few, not zero, but very few buoys in the Bering Sea, and most or possibly all of the real-time information is from the Pribilofs on south. Now there are various research moorings in the northern Bering Sea as well, but in general that data has to be retrieved by a ship and then post-processed. But a lot of what you see in real time, this kind of stuff, is derived from satellite. And that's why things like the race division's surveys are so important. Can do some stuff like gross estimates of sea ice extent or sea surface temperatures by satellite, but can't see into the water column, can't count fish from satellites, can't get an estimate of bottom water temperatures from satellites. Have to do that in situ.
Good question.
Yeah, thanks, because I know that NOAA was underfunded and things change depending on the administration. So hopefully they'll get their funding back up.
Yeah, the proposed budget for NOAA is pretty darn good. We'll see what happens, as always. You know, we'll take whatever we can get. That's for sure.
Well, I hope a lot of it's coming this way up north, so we get a good understanding. So well done. All right. Oh, you got a thumbs up from Mary. She's a Zoom pro. Any other questions for Rick? Any other questions for Rick? All right. With that,